Fourier series expansion k equal to minus infinity to plus infinity summation ak e to the power jk omega 0 t, where capital T, the time period, is equal to 2 pi over omega 0. This is the time period of this periodic signal, and we will make use of this Euler formula for expanding this signal. So ft is equal to 10 times 1 over 2j e to the power j 3t minus e to the power minus j 3t plus 5 times 1 over 2 e to the power j 9t plus e to the power minus j 9t. So this is 10 over 2j, that is 5 over j e to the power j 3t minus 5 over j e to the power minus j 3t plus 5 over 2 e to the power j 9t plus 5 over 2 e to the power minus j 9t. Now this can be represented in this way. I first write this one, so it's 5 over 2 e to the power j. Now I am trying to follow this series, so e to the power jk omega 0 t, so k in this case is minus 3 and omega 0 is 3. The next term will be this one, minus 5 over j, and then e to the power j, then minus 1, then 3, then t, plus 5 over j, then e to the power j, then 1, then 3, then t, plus 5 over 2 e to the power j, then 3, then 3, then t. So here omega 0 equal to 3, so this is equal to k, k is minus 3, so this is a minus 3, a subscript minus 3, so this is one coefficient equal to 3, and this is a sub 3. So this is an infinite series which has only 4 non-zero coefficients. So the non-zero coefficients are a sub minus 3 equal to 5 over 2, a sub minus 1 equal to minus 5 over j, a sub 1 equal to 5 over j, and a sub 3 is 5 over 2.
And the question is asking us to find Cn for signal xt. You can see the waveform of signal xt. It is a rectangular wave, and for this rectangular wave we are required to calculate the complex exponential Fourier coefficient Cn. And once we have Cn, we can easily find the Fourier series, because the complex exponential Fourier series for signal xt will be equal to summation n equal to minus infinity to infinity Cn multiplied to e raised to power jn omega naught t. So the process is very easy. The only important thing is the calculation of Cn. Therefore, in many questions you will find it is only asking to calculate Cn, because everyone knows after calculating Cn you can calculate the expansion. So in this question also we are required to find Cn only. Now let's move to the solution of the question. We know the formula. See, the range of integration should have the duration equal to the fundamental time period t0. Now look at the waveform given in the question. This instant of time is equal to minus t0 by 2, and this instant of time is equal to t0 by 2. And if we select this range of integration from minus t0 by 2 to t0 by 2, you will find the duration is equal to t0. So we have the range of integration, and in next step we will put the range 1 divided by t0 integration from minus t0 by 2 to t0 by 2 signal xt multiplied to e raised to power minus jn omega naught t dt. Now if you see the waveform, you will find the value of signal xt is equal to 0 from minus t0 by 2 to minus tau by 2, and the value of signal xt is equal to a naught from minus tau by 2 to tau by 2, and again it is equal to 0 from tau by 2 to t naught by 2. So xt is having three different values from minus t naught by 2 to t by 2. Value of signal xt is equal to 0. So 0 multiplied to e raised to power minus jn omega naught t dt. Now from the first and third integrals, we are going to get 0 as the final result. So we have 0 from the first integration and we have 0 from the third integration. So we are left with 1 divided by t naught omega naught t is equal to theta. Let's say minus jn omega naught t is equal to theta. Now to get very small value of theta, we should have very small value of time t, because all three j and omega naught are constants. So when we have very small value of time t dt, we are going to get very small theta, which is d theta. And from here we can say dt is equal to minus 1 divided by jn omega naught d theta. Now we are required to change the limits also, because minus tau by 2 and tau by 2 are the values of time t. So when t is equal to minus tau by 2, put t equal to minus tau by 2 here, and we will have theta. Theta is equal to jn omega naught tau by 2. And when t is equal to tau by 2, theta is equal to minus jn omega naught tau by 2. Now we will put these values in our integration and let's see what we have. We have a naught divided by, so we will have Cn equal to a naught, jn omega naught is constant, so we will take it out of integration. So we have jn omega naught t naught, integration from jn omega naught tau by 2 to minus jn omega naught tau by 2 e raised to power theta d theta. And we already know the integration of exponential function is equal to the exponential function itself. So we have, now in the next step, we will put the lower and upper limits. So now we will use the Euler's formula. We already know e power ix is equal to cos x plus I sin x. Now we will expand it using the Euler's formula, and we have Cn equal to a naught divided by j n omega naught t naught inside the bracket. E raised to power minus jx means cos minus x plus j sin minus x, because you can write e raised to power minus jx as e raised to power j minus x. So in place of x we have minus x, so we have cos minus x plus j sin minus x, minus e raised to power jx is equal to cos x plus j sin x inside the bracket to cos x, and sin minus x is equal to minus sin x, so we have minus j sin x. After this we have minus cos x minus j sin x. Cos x will cancel out, and we have Cn equal to a naught divided by jn omega naught t naught inside the bracket minus 2j sin x. X is equal to n omega naught tau by 2, so we have n omega naught tau by 2. And we have done one mistake here. This negative sign we have to consider, so we have minus a naught divided by jn omega naught t naught. Negative sign will come everywhere, so this negative and this negative will make the overall expression positive. So we have Cn equal to a naught divided by jn omega naught t naught, and here we have 2j sin n omega naught tau by 2. Now we will make this sampling function. We already know the sampling function. The sampling function is equal to sin t divided by t. In our case, in place of t, we have n omega naught tau by 2. So we will divide by n omega naught tau by 2, and we will multiply by n omega naught tau by 2. So you can see the 2 and 2 will cancel out. This 2 and 2 here will cancel out. J will cancel out. N omega naught will cancel out. So we are finally left with tau by 2. So this is the answer. We have calculated Cn for the given rectangular wave, and I have explained each and every step in great detail.